Welcome to AI Paper Recap. Today, we're delving into an innovative study titled Music Generation Using Human-in-the-Loop Reinforcement Learning. This research presents a novel approach to creating music by integrating human feedback into the reinforcement learning process, aiming to generate original compositions without relying on pre-existing musical data. The primary objective of this study is to develop a system that empowers musicians and composers to craft unique musical pieces tailored to their personal tastes. By avoiding dependence on existing musical sources, whether open source or copyrighted, the framework offers a fresh avenue for creativity. Additionally, it addresses a notable gap in the exploration of human-in-the-loop reinforcement learning, HIT-LRL, within the realm of music generation. The significance of this research lies in its potential to advance computer-aided music generation by eliminating the need for existing data. The proposed framework combines principles from music theory with reinforcement learning techniques, contributing to the field of algorithmic music generation free from data dependencies. This approach not only facilitates the creation of original compositions, but also allows users to fine-tune the model according to their unique preferences, fostering collaborative innovation among musicians. The framework comprises two main components, with user interaction at its core. The first component, termed the music generator, is responsible for creating music tracks. Users then rate these tracks on a scale from 1 to 10. The second component, the HIT-LRL agent, employs an episodic tabular cue learning approach with an epsilon-greedy exploration policy to adjust melodies based on user feedback. A graphical user interface, GUI, facilitates user input, enabling configuration of music generation, model training, and management. Reinforcement learning, RL, has been applied to music generation, with studies like Hong et al. Introducing deep RL methods for single-track MIDI music generation, emphasizing the incorporation of existing MIDI data for training and enhancing harmony. Similarly, Jin et al. Proposed a framework for metaverse concert generation, utilizing RL techniques and a Transformer XL music generation network trained on the POP 909 dataset, highlighting the importance of existing music data. However, these approaches rely heavily on pre-existing data sets. Human-in-the-loop HITL approaches have been employed in various domains to refine models through human feedback. In music generation, HITL methods have been used to guide the creative process, allowing for adjustments based on user preferences. This integration of human feedback ensures that the generated music aligns more closely with subjective tastes, enhancing the overall quality and appeal of the compositions. The proposed framework distinguishes itself by combining HIT-L with RL, aiming to generate music without pre-existing data dependencies. The music generator creates initial compositions, which are then evaluated by users. The HIT-L_RL_ agent adjusts the melodies based on user ratings, continuously refining the output through iterative feedback. This process allows the system to learn and adapt to individual preferences, resulting in personalized musical pieces. The system's architecture is designed to facilitate real-time music generation and refinement. The music generator produces compositions by leveraging principles from music theory, ensuring that the generated pieces adhere to fundamental musical structures. The HIT-L_RL_ agent utilizes an episodic tabular cue learning algorithm, which enables the system to learn optimal actions based on user feedback. The epsilon-greedy exploration policy balances exploration and exploitation, allowing the system to try new variations while refining successful ones. User interaction is central to this framework. The GUI provides an intuitive platform for users to generate music, rate compositions, and manage the model's training process. This interactive approach ensures that the system remains user-centric, adapting to the evolving preferences of the individual. By incorporating user feedback into the learning process, the system can produce music that resonates with the user's unique tastes. In summary, this study presents a novel approach to music generation by integrating human-in-the-loop reinforcement learning with principles from music theory. The framework enables the creation of original compositions without relying on existing musical data, offering a valuable tool for musicians and composers seeking to craft personalized music. By harnessing human feedback, the system continuously refines its output, aligning with individual preferences and contributing to the advancement of computer-aided music generation. Thank you for joining us on this exploration of cutting-edge AI research. If you found this discussion insightful, please give us a like and subscribe to AI Paper Recap for more in-depth analyses of the latest developments in artificial intelligence.